Okay, so hello there. We're going to continue with our batch of videos in mathematics in a modern world. We're still in our module in problem solving with patterns and puzzles. So we are done with our first pattern that we have a little bit discussed. There's too much to be to that we have had discussed already with the Fibonacci sequence. So the topic of Fibonacci sequence is quite short here. So we're going to explore this another pattern offered to us by Blaise Pascal. This is what we call Pascal's triangle. So the Pascal's triangle is obviously discovered by Blaise Pascal, who was a physicist and a mathematician. In the world of physics, I believe he is credited to be the first one to create the first calculator, that's the Pascaline. His name is also found in some units of measures. I believe it's in the unit of pressure, which is Pascal. And he's also in the field of mathematics. Is the one of the proponents of the uh, branch of mathematics called uh, probability theory, or simply probability, together with Pierre de Fermat. He's also a theologian. At the age of 25, he gave up his scientific and mathematical work to um, to give his time to God. However, as history suggests, this triangle has been around far before Pascal's time. So in India, it is called as a staircase to Mount Meru. In Iran, it is called as Khayyam's triangle, from one mathematician Khayyam. And in China, it's called as Yang Hui's triangle. Sorry if I mispronounced that. Okay, so how do we create this Pascal's triangle over here? So let me give you how it works. So first up, we want to imagine that we have a 1 here on the top, and we'll have this as our vertex, one vertex of a triangle. So we're going to imagine a triangle something like this. It's not the most perfect triangle, all right? So so what we're going to do is on the legs, along the legs of these triangles, we're going to put some ones there, one here, and so on. It depends on you how many ones you want, but let's say I'll take 1, 2, 3, 4, 5, 6, say 7, and I'll stop there. Eventually, you can delete the triangle, but you don't want to delete the one. So here in this empty space here, we want to input something in this empty space. So what we want to do is uh, input some numbers there. Okay, what numbers in particular? So we want to add 1 and 1 here to input anything on the to input this blank space. We want to add 1 and 1, the ones at the top of it. So two numbers at the top of it on the left and the right, we're going to add them and put them below that. It's strictly below it, between them. So what we have is 1 plus 1 is 2. Okay, 1 plus 2 is 3. So we're going to put the 3 here. 2 plus 1 is also 3. Next is 1 plus 4. 1 plus 3 is going to give us 4. 3 plus 3 is going to give us 6. 3 plus 1 is going to give us 4. And then 1 plus 5 is going to give us 5. 4 plus 6 is going to give us 10. 6 plus 4 is going to give us 10. 4 plus 1 is going to give us 5. Lastly, on our last row, 1 plus 6 is going to give 1 plus 5 rather is going to give us 6. 5 plus 10 is going to give us 15. 10 plus 10 is going to give us 20. 10 plus 5 is going to give us 15. 5 plus 1 is going to give us 6. Actually, you can continue this forever and ever. Now, first thing that we want to name is we want to call the rows. So we would like to call these, we will call this row number 0. We'll call them the rows as the number right after the one, the first one. So the number right after the first one here is nothing, so that's row 0. Here we'll call this row 1 because the number after the first one is 1. We'll call this row number 2. The number after the first one is 2. We'll call this row 3, obviously. This is row 4, row number 5, and row number 6. So that's how we call the rows of the Pascal's triangle. Okay, so row 6. Sorry. Okay, next is that you may want to see is that try to look at the diagonals here. So on these diagonals, we can see that the first diagonal here, pointing all the way to all these numbers, are all the set of all ones. So in particular, they are all ones, all the ones. In this diagonal here, starting from this number, going all the way this way, and also all the way this way, they're called the counting numbers or the natural numbers. Here, these numbers are what we call triangular numbers. Triangular numbers. Triangular numbers because it is the number of dots for us to create a triangle. So the exact number of dots that will be needed for us to create a triangle. So first one is the number 1, so we can put 1 there. And then the next one is 3. So we need 3 dots. So 1, 2, 3, and then we have a triangle. Next is 4. We will need to have rather 4, 6 rather, 6 dots. So we will add 3 here. So that we'll have 1, 2, 3, 4, 5, 6 dots to make a triangle. Next is 10 dots because we want to add 4 here. 1, 2, 3, 4. And as we have a 4 plus 3, 7 plus 3, that's going to give us 10 dots. And then 15 because we need to add 5 here. And that's why it's called, or they're called triangular numbers. These ones, also here, right? So these ones here are what we call tetrahedral numbers. Tetrahedral. So to give you the first two, so we need to start with a dot to create a tetrahedron. And we need 4. So imagine we have 1, 2, 3 here. So this is now a solid, right? So solid. And then there's a dot here, or rather there's a line here that connects the 2 dots below. So I think I can show you a picture later so that it will be more clear. Next fascinating thing about this Pascal's triangle is that try to add the numbers per row and try to look at the answer. So add 1 to nothing, so that's going to be just 1. Add 2 numbers here, so we have 1 plus 1, which is 2. Add 1 plus 2 plus 3, that's going to give us 4. Add 1 plus 3 plus 3 plus 1, that's going to give us 8. Add 1 plus 4 plus 6 plus 4 plus 1, that's going to give us 16. Next here is 1 plus 5 plus 10 plus 10 plus 5 plus 1, that's going to give us 32. And I bet this is going to give us 64. I believe you can see the pattern here. Okay, the first one, the pattern I can believe you can see is that all these numbers are powers of 2. So what we have is, this is 2 raised to 0 as row 0. This is 2 raised to 1. This is 2 raised to 2. This is 2 raised to 3. This is 2 raised to 4. This is 2 to the 5th. And this is 2 raised to 6. Okay? So that's one fascinating thing about it. Another way is that we can see powers of 11 right here. So how do we get to see the powers of 11? You just simply need to read each row. Let's try to change color. So let's say we want the color blue this time. So we just need to look at the numbers. So this is like 1, right? This is like 11. So where will I write this? So this is 1. This is 11. This is 1, 3, 3, 1. Or rather 1, 2, 1. This is 1, 2, 1. This is 1, 3, 3, 1. This is 1, 4, 6, 4, 1. Okay? And try to look at it that they're all powers of 11. This is 11 raised to 0. This is 11 raised to 1. This is 11 squared, which you can check by a calculator. This is 11 cubed. You can check that likewise in the calculator. And this is 11 raised to 4. 11 raised to 5 is quite challenging to see because there are digits, or there are numbers which has 2 digits. So what we want to do is we want to to carry this one to the next place value. So, this becomes 6, this becomes 0, but because of this becomes 1, and this becomes 0. So what we have is 11 squared is 161,051. So you can check that using your calculator to know if you're true or if you're correct. So actually we are. I just checked it with my own calculator. Also, let's do this last line here. So we have 1,615. This one here will be carried over, so this becomes 7. This 5 here will be added by 2. That's going to give us 7. This 0 here is going to be added by 1. This becomes 1. And we have 5, 6, 1. So we have 1771561. So that's going to be 11 raised to 6. It's going to give us 1771561. And you can verify that using your calculator, and the answer will be that 1771561, or 1,771,561. One thing you can also notice is that the Pascal's triangle is symmetric. It's symmetric in the middle part. So what do you mean by that, sir? It's symmetric because if I'm going to put some broken lines in this part of the triangle in the middle, you can see that it's a symmetric version. This one is a symmetric version of the other cell, and that's one thing special about it, because whatever the sum is on the left side, it will be equal to the right side. Okay. Now, there's a lot more to be talked about in the Pascal's triangle. So if you want, you may take a screenshot of this. I cannot go back to this part again, so I'll give it time. 5, 4, 3, 2, 1. All right. Now this is what the tetrahedral numbers, or tetrahedral numbers look like. So you can see that there's a 1 here, and a 4, and a 10, and a 20. And that's the tetrahedral number. And of course, you can also see the Fibonacci sequence there in the Pascal's triangle. If I can, I have here one more Pascal's triangle over here, and I'm going to show you one example how we can get the Pascal's triangle, or the Pascal's rather the Fibonacci sequence. Say we have this, it's going to give us 1, right? Here, it's also going to give us 1. 1 plus 1 is going to give us 2. 2 plus 1 is going to give us 3. 1 plus 3 plus 1 is going to give us 5. 3 plus 4 plus 1 is going to give us 8. 1 plus 6 plus 5 plus 1, I lost count. That's going to give us 13. 7 plus 5, 12 plus 1, 13. 4 plus 10 plus 6 plus 1. This is 21, which is correct, by the way. We have next is touching. Okay, 1 plus 10 plus 15 plus 7 plus 1. So this is right. This is 10, right? So 1 plus 10, it's going to give us 11. 11 plus 15 is going to give us 26. 26 plus 7 is going to give us 33. Okay, plus 1 is going to give us 34, which is pretty much correct here. Next is 5 plus 20 plus 21 plus 8 plus 1. Okay, so that's going to give us 5 plus 20, that's 25. Plus 21, that's going to give us 46. Plus 8 plus 1, that's going to give us 55. And indeed, that's still a Fibonacci number. And lastly, what we'll do is we will add 1 plus 15 plus 35 plus 28 plus 9 plus 1. And the answer would be 89. And that's pretty much a Fibonacci number. Okay, so those are some important characteristics of the Pascal's triangle. We can also use the Pascal's triangle in binomial expansion, actually. Okay, and I think that deserves our next video. We have talked too much about the Pascal triangle, and yeah, see you soon in the next video. Thank you very much for watching. Hope you'd like and subscribe, and make sure to see the watch or to see the next video. Okay, watch it and try to learn binomial expansion. Okay, so see ya.